Alright, welcome to the 5.7 video from Pre-algebra. We're talking about solving equations by clearing fractions and decimals. What in the world does that mean, clearing fractions and decimals? Well, clear, right? Clear off, get out, get them away, okay? So let's work on this first problem. We have negative 5/6 x plus a half, and it equals 3/4. And we're going to solve this, right, because it's an equation. We have a variable and an equal sign. And we're going to solve it by clearing, okay? Now, you might be saying, why clear? Well, you know, it's just another way of solving. Is it a lot easier? No, I would say it's probably just as easy as going, I need to subtract a half first, then divide by negative 5/6, which is really multiplying by the reciprocal, which is negative 6/5, to get x by itself. But let me show you anyway, because this is going to come in handy later on, especially in like Algebra 2. So, clearing. What do I have here? I have fractions. So I want to clear these fractions out, and here's how I do it. I'm going to find the least common denominator of all those fractions. So, the least common denominator is really just like saying the least common multiple. So what's the least common multiple of 6, 2, and 4? Well, let's see, multiples of 2 are 2, 4, 6, 8, 10, 12, 14, I'll stop there. Multiples of 6 are 6, 12, 18, 24, so on and so forth. Multiples of 4, let's see, 4, 8, 12, 16, 20. All right, so what is the smallest number in all of these that is shared? Well, he has a 4, but he doesn't, so it can't be 4. I see a 12 as the smallest number, the smallest multiple in each of these, and all three of them have a 12. So I'm going to multiply everything in this equation by 12. Let me show you what I mean. I'm going to rewrite our original, and I said I'm going to multiply everything by 12, so that's what I am going to do. So I'm going to multiply this term right there, because that is one term. Negative 5/6x is one term, by 12. All right. I'm going to multiply this positive 1/2 by 12. I'll put it on that side. I can put it on the front side too. It doesn't matter. And I'm going to multiply 3/4 by 12. All right. So let's work on one section at a time. 12 times negative 5/6x. Well, that's like saying 12 over 1, right? We know that. We can make it 12 over 1 times negative 5/6x. I'm going to assign the negative to the 5. So it's going to be negative 5 over 6. And then we have the x. And here's what I want you to kind of think of. If I said take negative 3 times 2x, you would say, oh, that's negative 6x, because you multiply the negative 3 times the 2, and then you just kind of tack on the x at the end. So I'm just going to leave the x out for right now, and we're going to tack them on the end. All right, so let's cross cancel. I have a 12 and a 6. If I divide both of them by 6, that becomes a 1, that becomes a 2, and then I multiply across the top. 2 times negative 5 is negative 10, and 1 times 1 is 1, so negative 10 over 1, I can just write that as negative 10. And remember, we have this x we're going to tack on the end. Negative 10x. Okay, so if we go back to that first little part, 12 times negative 5/6x is negative 10x. All right, let's move on to the next part. 1/2 times 12. Well, that's like saying what's a half of 12, and that's, of course, 6. And that equals... okay, 12 times 3/4. Well, we could make that 12 over 1 times 3/4. And I can cross cancel, divide that by 4 and that by 4. That becomes a 1 and a 3. 3 times 3 is 9. Over 1 times 1 is just 1, so it's 9, right? So what we've just done is got rid of our fractions, right? We have cleared the fractions. So now let's just solve it the rest of the way. Well, x is not by himself because he's being multiplied by negative 10. There's also a add 6. So let's get rid of the add 6 first by subtracting 6 from both sides, leaving us with negative 10x. Those cancel, equals 3. Now what's our last step? Well, we got to divide by negative 10 because it's a multiply by negative 10. Divide by negative 10 over there as well. those cancel, leaving us with just x equals, well, 3 over negative 10. That's just 3 over negative 10, right? Or we could say negative 3/10 is our answer. And that is how you clear fractions to get your answer. All right, so go ahead and give this one a shot. I want you to pause the video, try it, play when you're done. All right, so hopefully you were looking back on your notes, or you remember that if you're going to clear fractions out of there, that you need to figure out what the least common multiple of those three numbers are. Okay, 2, 10, and 5. So multiples of 2. 2, 4, 6, 8, 10. I'll stop there. Multiples of 10. 10, 20, 30. I'll stop there. Multiples of 5. 5, 10, 15, 20. I'll stop there. What is the smallest number present in here, in all three of these, that they all have? That would be a 10, right? 10 is the smallest number that all three of these have as multiples. And we're going to use that. But what do we do with that 10? Remember, we multiply everything by 10. So I'm going to rewrite the original, the little extra room in between everything. And remember, I'm going to multiply everything by 10. This is going to get multiplied by 10. This is going to get multiplied by 10. This is going to get multiplied by 10, right? So 10 times 1/2 x. Well, 10 times a half is 5, right? It's half of 10. So we're left with a 5x. Add to that, oh, well, if I'm multiplying 7/10 by 10, I can make that 10 a 10 over 1. So what happens here, though? Well, I can cross cancel, right? The 10 and the 10 become a 1 and a 1. So now I'm taking 1 times 7, which is 7, over 1 times 1, which is just 1. 7 over 1 is the same as saying 7. And that equals, let's see, 10 times 4/5. I need to make that 10 a 10 over 1. So can I cross cancel? Yeah. Okay. 10 and the 5. I can make that a 1 and that a 2 because I divided both of them by 5. 2 times 4 is, of course, 8 over 1 times 1 is just 1. 8 over 1 is the same as saying 8. So now, can we solve this? Yeah. Subtract 7 first, and we're left with 5x cancels equals 1. What's our last step? Well, 5 is being multiplied by x, so that's divide by 5 and divide by 5, and those cancel. We're left with x equals 1/5. And there, folks, is your answer, 1/5. All right, so let's introduce two new things at once. All right, we're going to solve an inequality by clearing not fractions but decimals. Okay, so I'm going to set this thing up. We have 2.3 is greater than or equal to 5.14 plus 0.8 m. All right, so what do? Well, you know what? We could just go ahead and, well, subtract 5.14 from both sides, right? We could. But here's how we clear, okay? And again, this is useful more kind of into Algebra 2, but it's good to kind of have an idea of right now so that way you're not surprised by it later. So, let's see. Clearing decimals. I'm going to look at all the decimals here, and I'm going to find the largest decimal place. What do I mean by that? Well, let's see. Here in this term, we have a decimal in the tenths. Here we have a decimal in the hundredths, 4. Here we have another decimal in the tenths. So what was the largest one? Well, the hundredths. So because the 4 was in the hundredths place, I'm going to multiply every single term by 100. Hundredths place, multiply by 100, right? So I'm going to set it up like this. This guy is going to get multiplied by 100. This guy is going to get multiplied by 100, and this guy is also going to get multiplied by 100. So when you multiply something by 100, remember it's just like moving the decimal 2 places to the right. So 2.3 becomes 230, greater than or equal to. Multiplying by 100 here, this decimal gets moved to the right twice. So 5.14 becomes 514 plus 100 times 0.8. Going to move him 2 places to the right. 1, 2, but it's 0.8 m. That's okay. We're going to pretend the m doesn't exist just for a second. So the 0.8 becomes 80, and then it was 0.8 times m, so we're going to make it 80 also times m. Okay, so we cleared our decimals out. Wow, how do we know that? Well, there are no more decimals, so that's how we know. So what do we do next? Well, next, we're going to solve it like we would any other equation. I have multiplication here that I got to break up, and I also have a positive 514 I need to get rid of in order to get this m by itself. Remember, the end goal here is get the variable, which is m, by himself on one side of the, in this case, it's an inequality. So we'll have some number here and some sign right there. So, going to subtract 514 first. Well, that could be a problem. Why? Because now we're subtracting negatives. But of course, we know how to do that. When you have a positive and you're subtracting, okay, and it's going to go into the negative because 514 is much bigger than 230. Remember, it's like taking 514 minus 230. We're going to find our answer then, but then we're going to tack on a negative on at the very end. So 4 minus 0 is 4. Can't do that. Make that a 4, bring the 1. 11 minus 3 is 8. 4 minus 2 is 2. So it's 284, but remember we're kind of just modifying it here a little bit. So it's actually going to be negative 284. Okay, so that becomes negative 284. Greater than or equal to, those cancel. You're left with an 80m. All right, so last step here. Well, the m is being multiplied by an 80, so we, of course, have to divide by the 80 to get that out of there. But if I divide that thing by 80, I have to divide the other side by 80 as well. So negative 284 divided by a positive 80 is going to get you a negative 3.55 there. And of our sign is greater than or equal to. So there you go. There's your answer. Negative 3.55 is greater than or equal to m. Of course, we could flip it around, put the m here, put the negative 3.55 there, which is actually the preferred way. But the sign was pointing towards the m, so we need to make sure it's still pointing towards the m. So this also reads m is less than or equal to negative 3.55. And just for review, if we were to graph that inequality, I would mark negative 3.55. I'd circle it and fill it in because it's less than or equal to, and because it's less than or equal to, shade to the left, less than left. And there you go. All right, guys, that is all that I have for you on this video. Look forward to seeing you in class and talking more about this later.